how that we use notation to represent a function. So remember, a function is a machine that takes some input, and that input is called the domain, and applies some rule to that input to produce an output, and the output is called the range. For each element of the domain, there is a single element in the range, and that's what makes it a function. So whatever we put in, we can only get one possible answer. So let's look at this example. We have two ways of notating functions. We either have f of x equals 2x minus 1, or we have the arrow notation, f takes x and maps it to this function, the domain and the range. Normally, the notation on the left-hand side is the one we use, and all we do to work something out is replace the thing that's in the brackets every time we see it. So if it's f of x equals 2x minus 1, and we want to find out what f of 3 is, all we do is we replace the x with 3. Remember that means times by it. So f of 3 in this case would be 2 times 3 is 6, minus 1 is 5. If we wanted to find f of a, then we just replace the x that was there with a. So let's have a look at an example. Given g of x is 3x plus 2 and g of a is minus 4, find for a, g of 3 is equal to 3x, so 3 times 3 plus 2, which is 9 plus 2 is 11. For b, we have g of 2 of x plus minus 1, g of 2x minus 1. All that means is every time we see an x in our function, we replace it with 2x minus 1. So this is 3. Instead of x, we write 2x minus 1, and then plus 2. But of simplifying, 3 times 2x is 6x. 3 times minus 1 is minus 3, plus 2, which gives us 6x minus 1. Finally, in part C, we're told to find a, and we know that g of a is equal to minus 4. This time we're working backwards. If g of a is minus 4, then we have minus 4 is this bit, g of a, is equal to this bit, but it has a in it, so it's 3a plus 2. So here we have g of a equals 3a plus 2, but g of a is equal to minus 4. Now we can solve the equation with minus 2, so we get minus 6 equals 3a, which means a equals minus 2. So that's the